I'm Eleanor from the KU Natural History Museum, and I'm so excited to welcome you to our awesome online event today. We'll be celebrating the fantastic variety of adaptations found among all sorts of different organisms in our Discovery Day Amazing Adaptations program. We have 14 terrific videos which cover everything from lichens to tapeworms to insects to vertebrates like lizards and mammals. These videos were put together by our fabulous museum curators, researchers, staff, and students, as well as by some wonderful community partners like the Baker Wetlands Discovery Center and Prairie Park Nature Center. Check out the museum's Facebook page for the full schedule of videos, with premieres happening regularly from 10 a.m. to 4:30 p.m. Can't stay all day? No problem. The videos will be available for later viewing on our Facebook page as well as on our YouTube channel. To get us started, I'm going to talk about some super cool insect eye adaptations, and then I'll show you how to make a pair of fly eye model glasses, inspired by an activity from the North Carolina Museum of Natural Sciences. For those of you who picked up a science kit last weekend, you're all set for this and the other activities being demonstrated today. But if you didn't get a science kit, you can still download the activity guides with supply lists and all of the instructions from our Science Kits webpage. Okay, so insect eye adaptations. First, what's an adaptation? If you watched my pop-up science episode earlier this month, then you learned that adaptations are evolutionary changes which enable an organism to become better suited to its environment. Eyes are truly remarkable adaptations that have evolved independently at least 3 different times throughout evolutionary time. The first eyes evolved about 555 million years ago during the Ediacaran period, when the first complex multicellular organisms evolved. Later, during the Cambrian explosion at about 541 million years ago, we see compound eyes really take off and provide a lot of evolutionary advantage to groups like the trilobites. In fact, all modern insects have compound eyes that are somewhat similar to those found in trilobite fossils. Now, what exactly is a compound eye? Well, first off, it's nothing like the human eye. Instead of a single chambered eyeball like ours, compound eyes are made up of many individual ommatidia, which are specialized clusters of photoreceptor cells surrounded by structural support cells and pigment cells that have a cornea on top. Each ommatidium can loosely focus light and can detect colors. Because ommatidia do not have pupils, they cannot control how much light enters the eye, meaning that they can't really focus the image. This means that insect sight is of low resolution or fairly blurry and imprecise. To try to work around this, some insects have evolved to have tons of ommatidia. Those with a large number of ommatidia practically have 360-degree vision, and they don't have to turn their heads to see things. The number of ommatidia in an insect's eyes vary, though, depending on the environment that the insect is adapted to. For example, dragonflies have up to 30,000 ommatidia. Other species, like some kinds of termites, only have about 20. In the middle are insects such as honeybees and houseflies, which have around 5,500 ommatidia. Many insects have both compound eyes as well as rudimentary eyes called ocelli that are simple light-sensing organs. You can see the ocelli on a housefly in the form of small bumps on the top of its head. Because flies are so sensitive to movement, you've probably noticed that it's really hard to swat a fly. You might be surprised to learn that although flies can see in a wide angle around their bodies, they're rather short-sighted. Flies typically only have a visible range of a few yards or less. This is because of that issue I mentioned earlier. Insect eyes don't have pupils for focusing light. The last insect eye adaptation I'll share is that insects see color a bit differently than we do. The photoreceptors in their ommatidia allow insects to see green, blue, and even ultraviolet light, but not red colors. Are you ready to make your own set of fly eyes and get a feeling for how houseflies view the world? Let's get started. For this activity, you'll need 2 paper plates, some bubble wrap, a pair of scissors, clear tape, a hole punch, 2 pipe cleaners, a pencil, and markers or crayons for decorating your fly eyes. The first step is to use the paper plates to trace 2 circles on the bubble wrap and then cut the 2 bubble wrap circles out. Then draw a circle on each one of your paper plates following the inside lip of the plate. You'll need to cut out these circles from your plates, and to make this easier, you can use the hole punch to create a hole along the line you drew and use it as a starting point for your scissors. Next, hold the paper plates together so that it looks like a big pair of glasses. Use the hole punch to create a hole going through both plates at the bottom and then at the top of the overlapping area. Then stick your pencil through the holes to hold your glasses together. Use the clear tape to attach the bubble wrap to the inside of your paper plates. Then wrap the 2 pipe cleaners at the top of the pencil to create 2 antennae. Finally, decorate your fly eyes with your markers or crayons. When you look through your fly eye model glasses, the bubble wrap represents the fly's many ommatidia. Each bubble represents a lens that would be at the top of each ommatidium. You'll also notice that the lenses make for big fields of vision, but the vision's kind of fuzzy. Remember that flies are short-sighted and they can't focus light very well. So this gives you an idea of what the world looks like to a fly. Well, I hope you had fun learning about insect eye adaptations with me today. Now stay tuned for many more videos about all sorts of other amazing adaptations, including more about insects, the bombardier beetle. Have a fun discovery day.